Right, lastly, I want to talk about coastal variability. So we live on a coast, which is one of the most dynamic environments on Earth, meaning it's a place that changes a lot very quickly. And sea level is one of the things that influences our coast. Thinking over the long term, right, geologic time scale, the cycles of glaciation and deglaciation when our temperatures, the global temperatures are much colder and then much warmer, causes water to be trapped in the glaciers and then drain back to the ocean and then trapped in the glaciers and drain back to the ocean. So this causes sea level rise and fall periodically. During the last ice age, which lasted from 2.6 million to 12,000 years ago, sea level was much, much lower, right? Because a lot of the ice was, or a lot of the water was trapped as ice and glaciers. So sea level was lower and a lot of land was exposed. So 12,000 years ago, if we stayed where we were, we would be nowhere near the coastline. The coastline would be way offshore where our continental shelf is now. So when the coastline was farther seaward, rivers and their channels also cut over the land farther seaward. Right? And then when sea levels rose, these river channels were drowned, which is one of the ways we have submarine canyons on our coastlines now. They used to be rivers when the water level was lower. So sea level has been rising since the last glacial maximum. And within the past few decades, it's been rising at a much quicker rate at unnatural levels. The rate of sea level rise is much, much greater than it would be without the influence of humans, without us warming our climate and continuing to melt the glaciers at a faster rate. So this is an image of what our coast could look like if there were 1.5 meters rise in sea level. That's like a 4.5 or so feet rise in sea level, which is not completely unexpected by the year 2100. And you'll see, right, if sea level rise continues on the path that it is, our coastline where we live could be underwater. Now that's on the very long term, right? That's thousands of years to hundreds of years to decades. On the shorter term, thinking hours to days to weeks, storms are very important for coastal variability. Storms come through, they have huge amounts of energy, huge amounts of wind, which is going to create a lot of waves, a lot of erosional power, and that can very quickly erode a coast away. Okay, so of the many important things you're going to learn in this class, I hope you learn not to invest your money in a coastal property. Right? If you do want to live on the coast, buy property high elevation, far away from the coastline. Barrier islands are a terrible place to invest your money in because they're just so dynamic. They're so variable. Now humans, we try our darndest to keep the land where it is, right? We don't want our barrier islands to migrate. We don't want our beaches to erode. So we often build hard structures to keep the land where it is right now. So groins, those are walls that are built perpendicular to the coastline. There's actually a groin on Sea Island if you've been there to see it. Jetties, those are those even longer walls that border an inlet. And then breakwaters, those are those walls offshore, oriented parallel to the shore. And every single one of these hard structures, these walls, are built to keep sand where it is now, right? To prevent erosion. Which kind of works and kind of doesn't, right? So here's an example of a groin, and you can see that when we build groins on the shoreline, because of longshore transport, sand is going to pile up on the updrift side of them, which means the downdrift side is going to become starved of sediment and it's going to start eroding. Okay? Now, this might sound familiar to you. Do you recognize this landscape? This landscape is just north of St. Simon's Island, just north of Gold's Inlet. You can actually stand at Gold's Inlet and look north and you'll see this landscape. This is Sea Island. And you can see that Sea Island built a groin. It's actually built two now. This image is a little outdated. There's two groins there now. And the groin was built to protect the very expensive homes and resorts updrift of that groin, where we see a lot of the accretion. But in doing so, starved the downdrift beaches. And St. Simon's Island is downdrift of Sea Island, which means when they built the Sea Island groin, they started to starve St. Simon's Island of sand. So I predict that more and more in the future, St. Simon's Island is going to continue to erode away because of the decision made to build a groin on Sea Island.